All right, so we're just going to kind of quickly go over the Grubhub, and this is just for the recording. So initially, we have menus, users, restaurants, and we're going to add in the additional columns and how they're all related to one another. But we're just getting the tables ready. All right, so we've got users, menus, restaurants. What else?
Orders.
All right, we have orders.
We had addresses.
And addresses. All right. So, is there anything else we need?
The repo mentioned service plans.
So we got service plans. What, like, I'm not familiar with Grubhub.
Are you doing Grubhub or Blue Apron? Because I think you mentioned both just for this one.
Oh, okay. Blue Apron.
Okay.
We'll do Blue Apron. Or no, I'm sorry, Grubhub. I don't know why I said, yeah, Grubhub. That's the one we want. Grubhub. All right. So when we think about menus, what items are on a menu?
Item prices,
Food, drinks, desserts.
So food, so like food items. So a menu consists of a lot of different food items. Is that right?
Yes.
Yes. So let me see. So we can call it like food items or something. I just want to try to get to this menu to menu relationship. All right. Or you can even do, yeah, like food items. It can be like just food or whatever. So a menu belongs to a restaurant. So I'm wondering, do we even need menus or can we just add? No, I think we need menus because a menu has a lot of food items. So under restaurant, we'll do like menu underscore ID. And is it like foreign key or like something like cannot be empty, foreign key. Does that work? Okay. There we go. So restaurant has a menu ID, and this is just assuming every restaurant has the same menu. Obviously, in the real world, depending on location, a restaurant might have a different menu, but we're going to keep things simple that like a restaurant has a single menu. And now a menu also has a bunch of different food items. But the same food item can technically belong to multiple different menus, such as, you know, we've got Burger King and McDonald's. They both have hamburgers. Now, what you call them might be different, but they're essentially, they've got very similar food items. So this is where like a many-to-many relationship would come in. And this is, you can call it a couple of things. It's called a through table. It's called a join table, but a join table is also, that vernacular is also used in SQL, like an actual join table is like a query. So it could be called a through table. and there's a couple of ways we can do this. If it's a true many-to-many relationship in that there's no additional attributes that are different between the food item and the menus, it's just this, like, for example, a hamburger can belong on a bunch of different menus, whether it's, a bar, whether it's McDonald's, well, it's like a high-end restaurant. They all might have burgers as a food item, so they can belong on different menus. And a menu can have multiple different food items. So that's where it's a many-to-many relationship. So a menu has many different food items, and a food item such as hamburger can exist on many different menus. So if that's the case, a many-to-many relationship, again, a menu has many different food items, and a food item can belong on or exist on many different menus, such as a hamburger can exist on a bunch of different menus. That is a many-to-many relationship. And the best practice, and we'll deal with users and addresses later, but I really want to get down to the many-to-many relationship. How you typically, so it goes a couple ways. You can explicitly define your through table or your many-to-many table or your join table. Some programs, if it's a true through table, you would name it like menu underscore followed by the other table you're joining. So food items. So, which again has just an ID, which is a primary key. And then it would also have a menu underscore ID, which is a foreign key to the menus.id. And then it would also have a food item ID, which would belong to the food items.id. Whoop. Why does that work? Food items.
You're missing your F key, your foreign key.
Yep, thank you. There we go. So that's how these tables are connected through this through table. But you can also have additional attributes on this through table, such as the price of this specific food item might be different on this menu or on like, what is it called? So like, for example, hamburgers, whatever. There's like a high-end hamburger place or not high-end, but like kind of bougie restaurant in this Wheaton right next to us. It's called the Burger Social or Burger Social. They got really good burgers or like gourmet burgers. And that price might be different from, say McDonald's. So you can add like a price on here as well, which is like an integer like that. So, and I guess I can call it like the name of it, but food item, hamburger, where's the food item? We can call it like name or specific, I don't know what it's called, like name, text or varchar. And you can just do something like that. So the food item of this would just be like hamburger. We can get into like specific name or like restaurant name if you really want to. Like 100 or whatever. And again, this is just for designing from like a design standpoint. So like a hamburger can exist on multiple different menus and you join them through this menu food items through table. And now each one will have a different price. Each one might have a different name for that hamburger or for that menu item. But yeah. So in this case, a food item can belong to many different menus, as well as a menu can have many different food items. Does anybody have any questions about many to many relationships? This is where things get, people get a little bit confused with regards to many relationships.
Yeah, I think I'm gonna have to rewatch the recorded lecture.
And so if that's so, all right, so let's not even worry about users and addresses right now. So I like to visualize it, and maybe this is helpful or not, through using like Excel or Google Sheets. Because if we remember, Gmail, if you visualize these, what am I? I'm going to open up Google Sheets. If we visualize these databases as essentially like spreadsheets almost, they've got columns, they've got rows, a table's technically a single spreadsheet. So I'm going to say like Grubhub. Grubhub is the name of this database. And we have sheet 1, which is the name of a table. We'll say menu. And we can make multiple tables, which is represented by a sheet. So menu, food, item, and I just want to get this food items, I guess menus and menus. That's plural. And we'll do another table, which is our through table, which would be menu, food, items. Let me break this off and make this smaller. Whoop. So I guess we can also do restaurants, but like, so for menus, we have an ID. That's all we really need right now. Just say ID for food item, menu food items. This is our join table. Say ID, menu, and I guess this will all be lowercase, menu ID, food item ID, price, restaurant name, and then food items. We also have an ID and a name. Let's actually go ahead and create restaurants as well. And this just has an ID. I guess we'll also have a menu name or restaurant name. Where'd it go? All right. So restaurant, we have restaurant name and menu ID. So let's create a restaurant. Does anybody have like a restaurant that they really like in their local area? Come on, someone has a go-to.
Coco's, COCOS.
Coco's, COC, like so?
Yep.
All right, so we'll just say menu ID is 1 initially. All right, so we've got menu ID of 1. All right, so name some things on their food item or on their menu that's really good. It could be drinks, it could be food.
Cutlet curry,
What is it?
chicken cutlet curry,
So chicken curry. What else we got?
some It's like a seafood curry. It's a curry spot, so they have a ton of different seafood. I mean,
Okay.
different curry.
All right. So we got chicken curry, seafood curry. And let's just go ahead and add a couple more just for fun, such as like hamburger, fries, and tacos. Why not? All right. So this isn't food items. So food items can consist of a bunch of different types of food items. So here it'd be just like a list of every single type of food item on just, it's not necessarily, it's not associated with any restaurant, any menu or anything. Just like, all right, I want to create a restaurant that serves, I don't know. Yeah, I don't even know.
Shaved ice.
What was it?
Shaved ice.
Shaved ice. Now let's go with what is it? Espresso martinis. If you haven't had any of those, I don't even know if I spelled that right, but if you have an espresso martini, they're delicious. I'll get you in trouble. All right. So we've got a bunch of different items, whether it's food items. Maybe this food items isn't the best name for this table because it doesn't just consist of food. It consists of drinks as well. But you can also have a separate table for that if you want. It just depends on how you want to architect and design your database. So we have restaurants, we have Cocos. So and all right, yeah, let's go here first. So we have menu ID 1 because Cocos has a menu ID associated with this menu ID. And let's see what food items we've got. Chicken curry and seafood curry. So menu ID is 1, seafood curry. 2, menu ID of 1 for that Cocos, and seafood ID. And we'll just say each one of these are $15.99. And I guess we don't even need restaurant name because that's probably not the best place to put it. Let's go ahead and delete that restaurant name. We don't need restaurant name because we can get to the restaurant name from food items or the food item table to the restaurant because they're all connected. So we can get to the restaurant name that way. So here, food item, we've got chicken curry, seafood curry, through the food items table, chicken curry, seafood curry. The menu ID is 1. So we go through the menu ID as 1, and now we can get to the restaurants because the restaurant ID or the restaurant has a menu ID of 1. So say, let's go ahead and create a new restaurant from scratch. Let's think of a restaurant. Does anybody have like an idea of a restaurant they want to create? A name of a restaurant. A name of a restaurant. So like not like an already existing restaurant.
3 guys.
3 guys?
It's like 5 guys, but not.
I'm gonna go with puzzles. I don't know. I'm just on the How I Met Your Mother kick right now. Puzzles. They created a bar called Puzzles, and everyone's gonna be like, well, why do they call it puzzles? And that's the puzzle. So it's gonna have a menu ID of 2. So if you go to menu ID of 2, and then, for example, maybe Puzzles on their menu, they also want to have seafood curry and chicken curry, but they also want to have hamburger, fries, and tacos, or hamburgers, fries, and espresso martinis. So they can say menu ID of 2, food item 3. So the food item is hamburgers, and we'll just say that is like $10.99 or $9.99, whatever. Um, and food item, let's say tacos and espresso martinis. Menu ID of 2 and 2. Was it 5 and 6? And tacos, $8.99. Espressos, martinis, sold $10 or whatever. So the way this is set up, since it's a many-to-many relationship, the same food item. Oh, let's also say that I also wanted chicken curry on here. But instead of charging $15.99 at Coco's, puzzles, let's just say it's more of a dive bar or whatever, and we're only going to charge, $12.99 for the seafood curry and $11.99 for the chicken curry. So the food item here is 1, which is chicken curry, but it belongs to the menu ID of 2, which belongs to the restaurant of puzzles. So here we have a bunch of different food items that can belong to or exist on many different menus, like so. So this right here, this menu food items is considered a join table or a through table. Because we both have like chicken curry here and chicken curry here, as well as seafood curry here and seafood curry here. So, but they belong to 2 different menus. And they also just happen to have 2 different prices on those menus. I don't know if that was helpful or that confused y'all even more. I don't know if that helped visualize things or not.
I think so.
I did.
Yeah, I think
Visual.
that helped a lot.
Cool. Awesome. All right. Did anybody have any additional questions or any other questions about any of the challenges on? Sorry, I have a dog in here that's making noises. Does anybody have any questions about any of the challenges from Saturday that they'd like to go over? Because now's the time to ask. No challenge, no questions? No.
Would it take too much time to go over one of the challenges?
Sure, let's go over like one of the schema challenges. Or is there a specific challenge, y'all?
Yeah, one of the schema challenges.
So we've got schema. Which one was the schema? So choose 2 of the 3 schemas you've designed, create different database for each schema and separate. All right. All right, let's go actually through Instagram. So for Instagram, again, let's use the software to create that schema. I just want to see if I'll be able to close this a little bit. There we go. So using food items. All right. Before I do that, let's go ahead and do fork it over. I'm going to fork it over Tom Preet. And open this up. Let me zoom in. Can you all see this or zoom in more? Is this too zoomed in or is this good?
It's good.
All right. So Tom Preet Schema Design 1. It's 1 because I already have one that exists. Git clone. Clear CD schema design 1. I'll list everything out. And I'll design it. What the hell? Don't save. So we'll just do Instagram and we'll go ahead and first design it out using this design software, this design app, and then we'll go ahead and actually run some seed data on it, create the schema in here, as well as create some seed data. All right. So, and again, let's just do like the very basic varchar. And we don't even need to, we can just use this as like placeholders as far as like what data type we want. We don't need to explicitly say the length of it yet. We'll do that when we actually go ahead and actually write our SQL schema file. So we've got users. I'm just going to copy this down as posts. So we've got posts. All right. So what should exist on the post table?
User.
Yeah, so posts. So let's see. Because who needs to make that post? So like user ID, foreign key, users.id. Like so. Because a post belongs to a user. All right. And we also need like content, the like content of that post. And we can make that like a text field. Like so. Maybe date posted. That's like a timestamp. So users, posts. What other things can you do on Instagram?
Like and comment.
Comment and like.
So we have posts, and this is where things get like interesting. Like, how do you differentiate a post? I don't know, I guess. Yeah, like and comment. Is it just like, or is it, can you only like things or heart things?
Yes.
Okay, so Instagram, you don't have like the various different impressions you can make. It's just
No.
likes. Okay, cool. That makes our life easier. Likes. So we have ID. Oh geez. What else do we need? So likes, and so I guess we would do like post ID. No. So this is all right. So what else would we need on the likes? So if I like something, what does that, and I store that like in the database, what else do I need to know about that like? I guess who posted it? Like, user ID or who
You would
liked
need to
it?
know you would also need to know the post ID. You need to know the user ID, but you need to know the post ID so you know what post got liked, or even
Yep.
a comment ID so you would know what comment got liked.
Okay. All right, there we go. So like post ID or so this is where it's like, all right, how do you differentiate between a post ID and a comment ID? You could do it one of a couple of ways, like so users.id, and this would be posts.
You need the foreign key.
Oh, thank you. So foreign key, or you can even do like, so we didn't talk about comments yet.
I know, he's getting upset that I'm not doing it.
So here, post ID. Okay, so, all right. So we even talk about comments yet. So I heard comments. And this is where, all right, we have comments, we have ID, it's a primary key. Then we have user ID who posted that comment. Now again, it's like, all right, because I think you can comment on comments, right?
Yeah,
Yes.
So when you
can
talk
reply to
about
comments.
comments, like, is it a comment on a comment?
yes.
Or is it a comment on a post? So you have to differentiate between those things. So you have to come up with like, all right, it's like, is it you can have like a comments table, which is probably not the best practice, or you'll have like a post ID, users.id, or a comment ID. Like so, let's see. But now this is where things get interesting. All right. So if you can comment on a comment, now it's like, okay, I always forget that foreign key. Let's see if this makes it for us. I just want to see if I do that. Post ID. Does it make it
You
for
also,
us?
you also need content for comments as well.
All right. Yep. Content. Text field. So here, now it's like, now this is looking weird. Cause like, so if a comment can comment an ID, comments, so here's where like, if a comment can have multiple comments on it, and a comment can belong to a single comment. So it's like, oh crap, should I? So how should that work? Or is this okay?
You could do something separate, and instead of making it a comment of a comment, make a new table of replies that would be specifically for things that replied to comments.
Yeah, so you can definitely do that. You can have an ID with a primary key, comment, ID. Foreign key, then we also have content. Whoop. Like so, and we also have users. So you can definitely do this as well.
Because then that would differentiate your replies to comments from your comments of posts.
Let's see, we got user ID, comment ID. Yeah, so this would probably, I'm just trying to think. And now here's the thing. Can you like a comment?
Yes.
All right.
I don't
So
think so, not on Instagram. I think you can,
No, let me look.
you can reply with an emoji, but it's a comment.
Let's look. No, you can like a comment.
so you can like a comment and
You can like a comment.
and therefore you can like a reply to a comment too, right?
Yes, you can.
Yeah. So this is where it's like, oh crap. All right. Now how, instead of like getting the circular, like, we have post ID. And then these are just like design decisions you can make. So you can say like comment ID here. Or like replies ID. So you can add. It's not replies.
But
And I'm
wouldn't
sure-
it also have two groups of users, like the user who whose post you're liking and the user who's liking the post.
Yes, but so in that case, you can get to whose user you're liking. So for example, I'm Tom, I'm liking George's post. So I like, say, George's post. So Tom's here. I can go to that post ID. So I can get to that post. And now I can say, hey, who posted that? Oh, George posted that. So I can get to George that way.
Awesome.
And under likes, we added status as a Boolean in order to determine whether or not it was liked or not.
Wait, say that one more time.
So we added status, so you could, as a Boolean, so that way, like if you clicked it, it would be true. If it was unclicked, it was
Ah.
false. So if it was liked or not liked.
Well, if that's the case, you would just delete it from the table then. So the first time you like it, it creates a record into it and it
Okay.
says is like, or where would that, where are you thinking that would go?
Under likes.
So is liked is a Boolean. And and this is like for data collection at point. So if I like, so initially
And
there's nothing in the database. I go to Instagram, I see Stephanie's post. I didn't like it yet, but when I like it, then it creates a record, says Tom Preet liked Stephanie's post with ID. These both will be nil or null or none because I didn't like a comment or like a reply. But then is liked would be true. And I'm like, oh crap, Stephanie's whatever. I accidentally liked it. So I dislike it, or not dislike it, but like uncheck it. But the like still stays in the record in the database, but then this turns to false. So I don't know, Facebook's pretty creepy. I wouldn't be surprised if they did something like that. Be like, hey, Tom accidentally liked somebody's post accidentally. It's like when you you stalk your
you're scrolling
exes,
or
you're scrolling.
oh no,
or
I
you
was
stalk your
totally
exes
scrolling
and-
and I hit the button.
yeah, exactly. Or like, oh my God, that time when I actually liked my ex's new boyfriend or girlfriend, and like, oh no, they know I was looking at their profile type of thing. I hope they didn't send out the notification that I liked it before it registered or whatever. So like you could have that, but you don't necessarily need that. So if I were to unlike it, if I were to like take that off, it would actually go ahead and delete that like.
Okay.
But again, that's an architecture database design decision that you could make. If you wanted to keep that, you could totally keep that just for like data collection purposes. It's like, Tom just like accidentally likes a lot of things, or he likes a lot of things after 12 a.m. All of a sudden at like 9 a.m. he's all of a sudden going back and unliking everything, realizing he's like an idiot and probably shouldn't be liking posts.
Espresso martinis, I think.
Yeah. Exactly. So yeah, you can totally do something like that. So what else do we have? What else can we add to this if we need to? I think this is not bad for right now. And there's probably I'm wondering if there's like a better way we can add, because I guess we can add date timestamps to comments and replies, but there's a lot of reused data in here, like content, date posted. So I'm sure there is a way we can have like maybe like a join table or like a through table, like a comment on a comment. So a comment can belong to a post or it can belong to a comment. And a comment, can you comment on other people's comments? So it's like a circular, like inception type thing, comment on comment on comment.
Those should technically then be replies.
Right. Yeah. In our scenario. So yeah, so exactly. So if I'm able to reply on a reply, it's like, all right,
Yes.
like, so I can keep creating tables that keep going down. But there has to be a cutoff at some point, or we can re-architect this with like like a through table, like we have comments and trying to think there's a way. So if we had a let's see. Comment ID, post ID. Anyway, oh, whatever. Like this works for now. Oh no, I don't want to delete that. All right. So we'll just say we'll forbid the user to comment on comments or no, comment on replies. That's just part of the constraint that we'll add. All right. So in here, I guess schema design, you can go ahead and create your schema in a bunch of different ways, but I'm going to go ahead and create a schema. So touch, Instagram, schema.sql, code, Instagram, schema. All right. So now we can go ahead and create our tables. So what I like to do, I don't know what that is. I'll just copy this entire thing over. Comment it out and go ahead and create my tables. So at the very top, I always do drop table if exists, users cascade. So we got users table, post table, comments table, replies table, and likes table. So users, posts, comments, replies. I think it was likes. Is that it? All right. All right, so under the users table, we can do create. Oh no. So create table, users of ID, serial, primary key, not null, but I don't think you really need to add that because I think it assumes it's not null anyway. Not users. And we can do like username, varchar, can make it like 100, or we can make it not null as well. All right. Whoop. So users name, do we need anything for users? I guess we can do like password. I don't know what else we want. Guess that's okay. Let's do posts. So create table, posts. We have ID. So again, ID. Content. Is it timestamp? Is that the right way? So again, I'm not,
Content should be the
oh,
varchar,
you're right. So is it varchar or text field?
varchar, and then however many characters.
Well, so varchar only allows us to go up to 255 characters. So if you want something more than 255 characters, SQL Postgres more than 255. I think it's just text then.
Text with size.
Look at the. I don't know what the hell.
You could do
that
a
is.
medium text. Holds a string of maximum of 16,777,215
I'm just gonna do, yeah.
characters.
Is it text? So I think we don't even have, we can just, I'm just gonna do text.
Text is just has a max length of 65,535.
Okay.
Yeah.
Yeah, I think we won't exceed that. What else with posts? So, oh. Date posted. Is that timestamp?
So timestamp is nothing more than the time a date time gives a date and time combination.
Date, time. So is it literally just date time? Or is
Yes,
it?
date. So this is date time. We had issues trying to use those, saying it wasn't that SQL didn't like it and we could only use date.
Okay, yeah, let's just use date for right now.
Yeah, Postgres didn't have that type of data.
No, yeah, it was Postgres that didn't like date time or timestamp.
All right. Then we won't use it. So ID, I'm sorry, integer, references. Did I spell that wrong? References, users. All right, so I'm gonna come down here, create. Did I create two of those? Whoa. Post, so we're gonna create comments. We're gonna content, date posted, user ID, post ID, references, posts. All right. I guess replies, same thing. But instead of post ID, it'll be comment ID. Oop. I'm gonna have to add those at the end of each one of them. So probably yell at me. I'll probably get rid of that. And then let's do likes. ID. User ID. Integer, references, users. Post ID, posts. It's probably overcomplicating things. There's definitely a different way to do this. Comments, reply. And we'll do is liked, why not? Is liked, Boolean. Because
You're missing a comma in the table above there. User ID, integer, references, users.
user ID,
The table above likes.
What was I missing? Replies, content.
Comma at that, on that line right there at the end.
Oh,
Bingo.
thank you. Awesome. So here for post, comment, and ID, so like either only one of them will typically have an ID associated with it. So like post ID might not exist, comment ID might exist. So it's like, if I like a post, then there'll be an entry here. Otherwise, the other two will be none or null. So yeah, the fact that there's going to be possibly 2 empty entries in those tables or in those fields, but it'll work. So let's go ahead and see if I can actually go ahead and create this. So what's the command to create a new database?
Create database.
Create DB.
Create DB. Let's call it Instagram. So I'm going to do PSQL Instagram to get into that database. I'm going to do \D to see any tables. Didn't find any relation tables. Does anybody know how to actually load the tables in from within here?
Not from within there, no.
Okay, there
Not
is a
from
way.
within the,
There is a way. I just don't remember off the top of my head. But yeah, you can just do PSQL Instagram. Instagram schema. All right, here we go.
I noticed on Saturday with just the syntax to that Chad was using a -R for, or no, a -F for file where you're using the left arrow.
Okay.
I assume that left arrow is just some sort of shortcut. It seemed to do the same thing.
Oh, so like -F, like so.
Yes.
I see that. All right, yeah, that works the same thing. So you can either use the angle bracket towards Instagram or the -F as well. They both will work, but yeah, I had a bug here. I was missing that thing right there. So I can PSQL into Instagram again. I can do /D to see all the different tables. So we got a table of comments, likes, posts, replies, and users. I can also go ahead and use Postico. So this is Postico. I can connect to it, go into Tom Preet, Instagram. You can see my tables there. And you can also inspect tables in here. So if I want to inspect the likes table, so \D likes, and you can see all the columns, ID, user ID, post ID, comment ID, reply is liked, etc. And all the constraints on here as well. All right. Questions on tables or database schema design? So that's one way you can do Instagram. There's other ways you can do it. Again, this is just an exercise. You can go as deep or as wide as you want. As far as like images and posting multiple images in a post, all that fun stuff. Any other questions? All right. Well, with that, we'll go ahead and take a 10-minute break.